Hi there, welcome to Eduretics, where we make your high school life simple. I'm Aniket, and in this video we're going to discuss something really important. So if you're on this video, I bet you've heard of this word multiple times. That's regression. You must have heard your friends saying that they've solved some really tough problems on the SAT Math using regression, or you must have read this on Reddit or on YouTube, that they claim to solve some really tough questions, specifically on the module 2 of SAT Math using regression on DESMOS. So what the heck is DESMOS? That's what we're going to check out today. Okay, and make sure you follow this clearly, because regression is a very important feature of DESMOS and might get you at least 20 to 25 extra points on your module 2 and module 1 end on SAT Math. Okay, so let's see what regression is. Regression by means extrapolating using some given amount of information to get an accurate idea of the actual thing. Okay, so for us, what is its relevance? Its relevance comes when we get questions where we're getting coordinates. We're given some information. Let's say we get two coordinates, 2,3 and 0,6. We're getting these 2 points, and the question asks us what is the equation of the line, or what will be the y coordinate when the x coordinate is 7, that kind of a thing. So for that, we'll have to use these 2 points and figure out the exact equation of the form y is equal to mx plus c, and then put in x as 7 to get the thing. So that's the process. You use these 2, you go to y is equal to mx plus c, you figure out m and c, then you put x is equal to 7, and the output you get the y coordinate. Okay, this process can be time taking. Okay, and this thing is eliminated using DESMOS. So let's see how we can figure out the equation using DESMOS. Okay, so on DESMOS, you usually are habitual to put in some equations like x squared plus 5x plus 9, something like this, and it graphs it on this side, on the right hand side. Okay, but now here in this case, we'll make use of another feature which is used to input the coordinates. So go to the plus sign, click on table. Okay, you won't get all of these 5 options on your test DESMOS, on the SAT testing DESMOS. That's a different version of this, which has just 2 options, the table and expression. Okay, so that's what you need. So on the table, let's put the same coordinates. Our coordinates were 2, 3 and 0,6. So 2, that's x1, 3, and the second point 0, 6. Now, as you can see on the right hand side, the points are plotted, but you cannot do much with these just 2 points. We can see their location, but what help does it do? Unless we can actually graph this with the real equation. For that, we follow something called regression, linear regression. So follow closely how we write it. y1, we don't write simply y, we write y1. And then we don't write equal to, that's wrong. We write a tilde sign, which is just on the left hand side of the numerical 1 key on your keyboard. Okay, so tilde. Now what's the general equation for a straight line? Y is equal to mx plus c. In regression, you'll name the constants as b0, b1, b2 like this, not m and c. So I name m as b0, c as b1. So mx plus c, that means b0, x, not x but x1, plus c would be b1. See the equation, the graph is plotted accurately wherever you need it. Okay, and we have got the constants as well. The slope is negative 1.5, and c, which is the y-intercept, that's a 6. Plot is already done. Next thing, what did they ask? They asked what's the y coordinate when x is equal to 7. How can we do that? Simply match the point of intersection of this graph with x is equal to 7. I write x is equal to 7. It's here. Let's go to this point, click on any of the 2 lines, the point is indicated, 7, negative 4.5. So the y value, corresponding y value is negative 4.5, and that's also our answer. Okay, so this is how, simply with just the points and writing the general expression, we're able to find out the exact graph and the equation. Okay, let's go and let's try out some actual SAT questions. Okay, if you look at this question, the graph of the equation ax plus ky is equal to 6 is a line in the xy plane where a and k are constants. If the line contains the points, there are 2 points given, negative 2, negative 6 and 0, negative 3. These are 2 points, 1, 2, and this is the equation given. It has two constants that need to be figured out, a and k. What is the value of k? Now the usual approach will need you to figure out the exact equation using these 2 points by plugging in these 2 points in the equation and then finding out what's the value of k. We can do this using DESMOS. Again, I'm reiterating the steps for regression. First of all, you put in, step 1. Okay. Step 1 is write the coordinates in the table. Write the points in the table on DESMOS. This is on DESMOS. Okay, write the points in the table. Step 2. Write the general expression. Step 3. Write the regression expression. That's it. So, what do I mean here? I mean these 2 points, -2, -6 and 0, -3. These 2 points are written. That's step 1 done. General expression. What function are we writing? We're writing a linear equation here. So what's the general expression? Y is equal to mx plus c. Now write this as a regression in DESMOS using the rules I told you. So we write y1 tilde b0 x1 plus b1. This is the regression expression corresponding to y is equal to mx plus c. So let's see this on DESMOS. Okay. So first step, input the table, -2, -6, 0, -3. The points are plotted. Next step, y is equal to mx plus c. Let's write it in the regression format. y1 tilde b0 x1 plus b1. You see the slope is 1.5, y-intercept is -3. Okay. Now in the question, what are they asking exactly? They're asking us, they've given us the equation in the form of ax plus ky is equal to 6. If I write it in the form of y is equal to mx plus 6, I get y is equal to negative ax over k plus 6 over k. Okay, so the c are constant from DESMOS. What do we have? -3. 6 over k is equal to -3, k is equal to -2. Option A is the correct one. Okay, so once you're in good practice, this is hardly going to take 10 to 15 seconds. Okay, let's check another question. Let's check this question. When you read this question, that's where you need to take cues as to whether you should use DESMOS or not. So let's see. An economist modeled the demand Q for a certain product as a linear function of the selling price P. So two quantities Q and P. These are the two quantities. And the demand was 20,000 units when the selling price was $40 per unit. And the demand was 15,000 units when the selling price was $60 per unit. Based on the model, it's a linear function model that's mentioned already. What is the demand in units when the selling price is $55 per unit? Okay, so they've given us two scenarios. Let's write P, Q. P is the selling price, Q is the demand. So P is basically X, demand is Y, because we're checking the effect of X or effect of selling price on the demand. Okay, so P, selling price, when it's $40, the demand is 20,000 units. When it's $60, the demand is 15,000 units. So you see the demand decrease with increasing price, and that's pretty obvious, that's natural. Now they're asking us what will the demand be when the selling price is $55. So obvious approach is to go ahead, form an equation, then put X as 55 and find out the value of Y. But what's the nicest or the best approach? That is to head to DESMOS straight away, because you see equations, you see inputs, 2 points, you need to form the equation and you need to find out the answer. So we go to DESMOS and use regression for this. Let's check. So first step, we add the table here. For the points, let's see. It's 40, 20,000, 60, 15,000. 40 comma 20,000, 60 comma 15,000. You'll need to adjust the scales a bit in order to see this properly. If we see it here, we won't be able to see the points, so let's adjust the scales. We'll adjust the Y scales. As you can see here, I'll just show this. So on the Y-axis, I'm going to put in the steps as the range would be up till 40,000, beginning from, let's say, minus 5,000. And since the demand cannot be negative, so we don't need to worry about what range we are taking on the negative Y. And the step, let's take a step of 1,000. So the points are visible. And we'll have to adjust the X as well, because X is also higher. So on the X axis, I'm going to take 100 to minus 100, or even minus 100 is not required. You can just simply take minus 10 on the negative X to be represented on the graph. Now we have our points, and the step can be 10 units. Okay, now the steps are adjusted. We'll write the regression. Y1 tilde B0 X1 plus B1. Formed. Our equation is formed. You can see with increasing selling price, the demand is going down. Now they asked us what's the exact demand at selling price of $55. So simply put X is equal to 55. And here's the point of intersection. At $55, it's 16250. That's the demand. Let's check the option 16250. Straight up option A. It's that simple. No need of working out anything. No chance of calculation mistake because you've not solved anything at all in this question. Everything is solved by DESMOS. Now, similar to linear equations or linear functions, the DESMOS regression can be extended to any type of function, whether exponential or quadratic or cubic or any other. So let's see. So on the SAT, the relevant functions are linear, quadratic, and exponential. So we'll stick to those. And then in another video, we'll be talking about trigonometric functions. Okay. The total distance d in meters traveled by an object moving in a straight line can be modeled by a quadratic function. That's what they've given, quadratic function. That is defined in terms of t, where t is the time in seconds. At a time of 10 seconds, total distance traveled is 50 meters. At a time of 20 seconds, total distance traveled is 200 meters. If the object was at a distance of 0 meters when t is equal to 0, that means initial point was 0, 0, then what is the total distance traveled in meters by the object after 30 seconds? So, object moving in a straight line and its motion is modeled by a quadratic equation against time and distance. So, as we can see, the quadratic equation can look like this or the other way around. And they say at a time of 10 seconds, so let's represent the seconds on the x-axis, t, and the distance on the y-axis, distance. Okay. So at 0, 0, it's starting from 0, 0, the same. So starting from here. And at 10 seconds, the distance traveled is 50 meters. Corresponding to this, it's 50 meters. And then at a time of 20 seconds, the distance traveled is 200 meters. At 20 seconds, it's 200 meters. We don't exactly know at what points on the quadratic graph do these values lie. So we're just taking that. Okay. And they're asking what is the total distance traveled in meters by the object after 30 seconds. So 10 and 20 are known. We need to check the d against t is equal to 30 seconds. Now we can think of formulating the quadratic function and then putting it t is equal to 30 seconds. But let's do regression instead. We have the points. We have the general expression as y is equal to ax squared plus bx plus c. So on regression, this would look like y1 tilde b0 x1 squared plus b1 x1 plus b2. Okay, let's go ahead to DESMOS and check. Okay, so first we input the points using the table. Okay, so those are 10, 50 and 20, 200. 10, 50 and 20, 200. Okay, These are the points. Now we write the regression expression. y1 tilde b0 x1 squared plus b1 x1 plus b2. Okay. Here is the quadratic expression. Okay. And we need to check for x is equal to 30. X is equal to 30 seconds. So we'll need to adjust the x-axis here by a bit. So x-axis, let's put between 50 and negative 50, or negative 10 and 50. And the step would be 10 or, yep, okay, we can take 10 as the step on the x-axis. Adjust the y-axis for 300 on the positive side. Okay, or maybe even higher. Let's do 700 on the positive side to be able to see the point of intersection. So both the points are now present here. X equal to 30 is given. Click on any one of the graphs, you'll get the intersection point. 30, 450. 450 meters is the answer. That's the distance covered after 30 seconds, going by the information that was already given. So that's your answer. No solving at all. Again, everything solved using DESMOS. Regression using DESMOS. Okay. So this is how we do regression. Make sure you practice this with all different functions. It's possible for all functions. Just make sure you write it in the correct expression, correct general form, okay, and put in the correct points. So to practice more on DESMOS, you can go to the other videos that are attached here. You must be seeing them in the associated or related videos with 2 parts of DESMOS problem solving. Make sure you practice them thoroughly, because this will matter a lot on your SAT Math, specifically Module 2. Okay, and let me know if there are any questions or anything you need to be solved. I can take it up in the next video. Okay, stay tuned. Bye-bye.